looking for a clean, efficient source of energy to be used in the colonies. Tidal energy is a great renewable energy source. We hope you enjoy the following presentation. Please help us fund this project.
Tidal has a lot of environmental impacts. One positive is it decreases the emission of gases responsible for global warming and acid rain. This will cause the environment to be more sustainable. Another positive is it decreases the need for nuclear power. Nuclear power emits a lot of radiation and is very harmful to the environment and humans. A negative, however, is changing tidal flows by damming a bay is bad and it impacts the aquatic and shoreline ecosystem, navigation, and recreation. Another negative is that local tides are decreased by 15 centimeters. Over time, this will add up, causing tide waves to be not as high and not bring in as much energy as it did in the beginning.
Now, annually receives 2,100 terawatt hours of incident wave energy along the coastlines. The usage of this energy is described as net energy yield. The net energy yield depends on the location, the size, and the production of a tidal power station. An example of these dynamics for a tidal power station is Lawrence. This large-scale tide energy project was installed with a total capacity of 240 megawatts generated from 24 turbines. Annual production is around 0.6 terawatt hours, and that's 600 gigawatts an hour. This means that the average net energy yield annually is 68 megawatts, and this can be calculated by the equation E equals 0.5 APGH squared. Tidal barrage power schemes have a high capital cost and a very low running cost. As a result to this, tidal power may not produce returns for many years. There are three main types of wave energy technologies. One type uses buoys, floats, and pitching devices to generate electricity using the rise and the fall of ocean swells to drive hydraulic pumps. The second type uses an OWC, an oscillating water column that generates electricity through a cylindrical shaft. The third type is a tapered channel located offshore. These technologies contribute to net energy yield.
How it works. Tidal energy is a form of hydropower that converts the energy received from tides into other useful and efficient forms of power. Tides are converted into mechanical energy as the water is released through large turbines that create electrical power through the use of generators. The height differences between high and low tides create tidal currents in coastal areas, and these currents are strong enough to drive turbines. Tidal generators are very similar to wind turbines, except it is the ocean currents that turn them. The spinning turbines produce the electricity. Because tidal energy is both renewable and a very efficient way of generating energy, it possesses great potential. The large density of water results in high amounts of energy to be produced from the tidal currents, even if the speed of the current is not very fast in a particular region.
Obtaining this energy from the tides is very expensive. The turbines used to get electricity cost millions of dollars. Although they are expensive and may not produce returns for many years, they also have a very low running cost. The turbines only need to be replaced once every 30 years. Tidal behavior is easily predictable. It means that tidal energy can generate power for a defined period of time. Tidal energy has a high energy density, meaning that the tides store a large amount of energy than most other forms of renewable energy, such as wind. Thank you for listening to this presentation. Your funding will help our community become sustainable.